Good evening, I am Gopi Krishna Rao. Today we will see how to interface an LED with STM32 F103 microcontroller, ARM based microcontroller, and create an application of blinking of the LED. So the requirements are: have the Keil and the Proteus, open the Proteus environment. After you open the Proteus environment, move to File, select New Project, define the name of the new project, say LED 1, click on Next, select Default, do not create a PCB layout, no firmware project, and finish. So you will get a window of this form. This gray window is the workspace where you create your project. On to the left of your screen, you see a lot of terminals available, which are oscilloscopes, power supplies, voltmeters, ammeters, watt meters are all present on the left. On the screen, right click, select Place, Component, and then from Libraries. In the keyword, type the microcontroller name STM32 F103 C6. So this is a microcontroller. Say OK. Left click on a location wherever you want to place it on the screen. Use a scroll button to increase the size of visibility. If you want to flip this, right click on the microcontroller, select X mirror, and this is an option that you get in. So we need two more components here. One is a LED, the other one is a resistor. Right click on the screen, go to Components, Libraries, search for LED. In optoelectronics, you see there are a lot of LED with active option present. So I would select LED yellow, active, place it on the screen, get a resistor, select 0.6 watt metal film, select any value of the resistor. You can change the value of the resistor, place the resistor, double click on the resistor, change its value to 220 ohm. Now move to pin. So I would like to connect it to port A pin 6. So let us say we connect it to port A pin 7. Okay, for the simplicity, drag. So you see a bubble coming at the terminal. Click, drag the wire. Again you see a terminal here. Click it. In similar fashion, connect the LED. Now see, the negative terminal of the LED is connected to the port pin. So the positive terminal should be connected to the power. In the left part, you see terminal mode. Select this. Inside this you have power. Select the power, place it on the screen, connect it to the LED. So the physical connection of LED to port A pin 7 is done through a resistor. So there are two more aspects that we have to do here. One, fixing the frequency of operation of the microcontroller. the other one giving the power supply to the microcontroller. So first we will give the power supply to the microcontroller. In the toolbar, go to Design, Configure Power Rails. So in the Configure Power Rails, you see unconnected power nets. There are two, VDDA, VSSA. VDD stands for positive, VSS stands for ground. So you need to connect it to the net list. Here at the name, you see ground. Select VSSA, say add. Then change it to VCC. We are operating on CMOS based devices. So change this to 3.3 volts. Select VDD A and add. Now the power connections to the microcontroller are done. The next one is a frequency that we have to define to the device. So double click on the microcontroller. Here at oscillator frequency, the value is default. Change this to 72 megahertz. Change this to 72 megahertz and say OK. Now the primary configuration is done. Now we have to write the logic to the microcontroller for the LED to flash or blink. So the program is written in the Keil environment. Go to project, select a new mission project, define the name, say LED slash, I'll give today's date, LED, today's date, save it. Now instead of selecting legacy, select power packs. In the search we used STM32 F103 C6 in Proteus connection. Select the same microcontroller here and say OK. Give me a minute. So little error. So, LED 11, save. So select STM32 F103 C6. Say OK. This pop-up comes in. At CMSIS, select core. At device, select startup. Click on resolve and press OK. On the source group, right click, add new item to the group, select the C file, say let me say I give the name LED 11, add. So now you see the C file is created. Now let us write the program for it. The first line is include STM32 F10x .h. This is to call the library of the microcontroller. Next we will call a delay program, void delay milliseconds with the name variable unsigned integer 16 bit. We will enter into the main body of the program. The first step is turning on all the ports. So APB to ENR. XFC. The next one is defining the direction of the port. So we have connected it to port A pin 7. So it comes in the lower part. So CRL. Output is defined as 3. So pin number 7 is 3. The remaining pins are all input pins. This is the setup. Once a setup is done, we will write the logic. So we will create an infinite loop using while function. Within this, we will write the function. First, here for a LED to glow, if you make this pin 0, the current will flow through the LED and the LED will glow. If you make pin 1, the potential at both the terminals are same, the LED does not glow. So we will use a bit function here. We will use a bit function here in the Keil environment. So here we will write GPIO A BRR, bit reset register. Which pin we want to reset? Pin number 7, so that the LED will turn on. So we will call a small delay of say around 100 milliseconds. After 100 milliseconds, we will try to turn off the LED. To turn off the LED, we will use BSRR. So which pin we have to make? 1, pin number 7, to which the LED is connected. So we have made that as 1. So again call a delay of say same 100 milliseconds. So this ends the logic and the main. So we will write the delay routine here. Delay milliseconds, unsigned int, unsigned long L is equal to 0. For unsigned int 16t I is equal to 0, I less than t I plus plus. So we are writing a nested for loop here. For L is equal to 0, L less than 6000. This is a calculated delay for 1 millisecond. L plus plus, and we close the loop, close the delay loop. So this is the end of the program. So what we have done here, we have called the library, called a delay function, then we enabled the clocks of all the ports, defined port A pin 7 as output. In a while loop, first we sent 0 to port A pin 7, called a small delay, then again we sent 1 to port A pin 7, called a small delay. In the delay routine, what we have done, we have used nested for loops so that we create a software delay. Once this is done, save the program, check for errors. There are no errors. So before you compile, go to the target, select options for target. Here at the output part, you have to generate the machine code. So select create hex file. Remember, you have to create the machine code. So select create hex file and select it. And after that, save it, compile it. So once it is compiled, you can see at this part creating hex file. So this hex file is nothing but the binary file, which is the machine code. Now the file is done. Go to the Proteus environment. You have to dump the code into the microcontroller. So double click on it. So you see the program file option here. Browse and try to find the one. The name that we had saved was LED 11. The name that we had saved was LED 11. So here we have. So we have dumped the hex code. Done. Then run the code. So now do you see LED flashing on the screen? LED is flashing on the screen. So this is how we create a Proteus environment for interfacing of an LED and writing a program on Keil for blinking and generating a machine code hex file and transferring it into the microcontroller. Hope this will help you. Thank you.